I'm still working on building the skeleton from Make Human in Godot 4, but when I imported the skeleton from Blender, I realized that the mesh that I had generated using the SurfaceTool, so the shaded and with all of the blend shapes, was not properly linked to the skeleton, so the animations didn't work. And that's because the bones and weights arrays weren't being set. So you can see that I do have it mapped to the skeleton now, and it does have all the shape keys. If you reset the pose, then you can change these and everything's fine. Of course, if you change the pose and try to change the shape keys, then it gets distorted because I still need to build the skeleton, but I will do that next time. So this time I'll just show you how I got the bones and weights arrays working with the SurfaceTool. And there's also a link to the source code in the description if you want to check that out. First, I'll open up a new Blender project so I can make the default skeleton for the basis mesh. So I'll make a new human from scratch and create using the default parameters. Then under data, I'll set all of the shape key values to 0. This will create the basis shape. Then under rigging, I'll add the Mixamo rig. So now it has the skeleton. Then under operations and base mesh, you'll want to export the Mixamo reduced all. To FBX object, and you can delete the mesh that it created. Now I'll open up mixamo.com from Adobe and upload the FBX object Mixamo reduced all and let it process. And once it's done uploading and rigging, you can select any of the animations and change the settings if you want. And download the FBX binary without skin. So this will save as an FBX as well. Then in Blender, I'll import the FBX object file for the animation. And you can see the skeleton is there doing the little dance. So with the human rig reduced selected, select the original human.rig, holding Control to select multiple. Then under Operations, Animation, click the Snap to Mixamo. So now the mesh follows the skeleton. And you can remove the helpers through the menu, but I actually need to keep all the vertices, so If you select the human mesh and click the blue wrench, I'll get rid of the hide helpers modifier so that the blend shapes can be accessed in Godot. And then I'll save this over the human.blend in the Humanizer project. Now in Godot, once it's done loading, you'll want to drag the human.blend file into a new scene and reset the transform. Right-click the human node and click Make Local to expand the nodes. So you can see the animation player is attached to a separate skeleton currently. So if you have only one animation, you can just rename the nodes here. And if you have multiple animations, you'll need to copy them from a new scene using the tracks. But I already have a video about that, so to make it simple, first you'll delete the human rig reduced. Make sure delete related animation tracks is disabled. And then I'll rename human rig to reduced. So now the animation is mapped to that skeleton. And then you can change the name back to whatever you want. So the animation still works. I can add the hide helpers material that I made a couple videos ago. And you can still apply the blend shapes, but the mesh gets deformed with the skeleton, which is what we're trying to fix. Now I want to use the generated meshes with the shape keys and the shading instead of the default mesh. This has only a few shape keys. So if I drag the generated human skin and assign the skeleton, you can see that it is not attached. That's because I need to rerun the import shape keys and the generate shading to add the bone weights into the meshes. And you'll want to make sure in the advanced settings on the blend file that you have the mesh saved to a local resource so that it updates. So now you can see that the generated mesh completely disappears when it's assigned to the skeleton. However, the unshaded mesh does seem to map correctly. So I'll need to fix that before I can build the skeleton. Ideally, I could just add the normals and tangents directly to the import shape keys mesh. And I did find a function in array mesh called regen normal maps. And it says it regenerates the tangents for each of the array mesh surfaces. I did try that and it didn't work, but I'll go ahead and show you what I mean. So first, under make mesh, after it adds the surface, if you just call the regen normal maps function before you save it as a new mesh and run that, you can see that the mesh disappears and it throws a bunch of out of bounds errors, and this persists even if you reload the scene. So I thought it might be because the normal and tangent arrays were null. So if I just revert that and set the blend shape, normals and tangents equal to the mesh array just for a placeholder, and get rid of the basis shape for now, and I rerun it, it still throws the errors once it tries to load the scene, so that didn't work either. So I figured I should get rid of the process shape keys altogether. So now it does not throw an error, and we just have the basis shape with the default shading. But I wanted to remove the shading so that I could see if the regen normals worked. So if I reset the normal and tangent arrays to null on the base mesh and run it again, you can see that I need to reload the scene because it has the old shape keys. So now, if I override the surface material, you can see that it is still unshaded, and the regen normals didn't seem to do anything. So if I, instead of setting this to null, fill the normal with vector 3.0 and the tangent with 1, and try to rerun it, you can see that it's still unshaded even though I call the regen normal maps. So that's not going to work, and I'm still going to have to use the surface tool to generate the shading on the shape keys. So in the generate shading scene, I'll go ahead and ignore the blend shapes for now and use the surface tool that we declared up there to create from the unshaded human mesh on surface 0, and I'll set the mesh arrays equal to the surface tool dot commit to arrays, and now if I run this, you can see in the skeleton builder the shaded human is still not mapping to the skeleton correctly. So if I reset the skeleton, it's there, but if I try to set the skeleton, it disappears. So in the generate shading class, before I add the surface from arrays, I'll get the surface arrays from the unshaded human.mesh, and I'll set the mesh arrays bones array equal to the surface array bones array, and then I'll set the weights as well from the import mesh to the export mesh. And now if I run this and go back to the skeleton builder, you can see that the unshaded generated human mesh from the surface tool is now mapped to the skeleton. But whenever I try to generate the tangents and normals using the surface tool, and run the generate shading, you can see that the mesh is gone again, and that's because whenever you create from the mesh, it has the same number of vertices as the import mesh. So if we were to print the commit to arrays mesh dot vertex array size before and after I generate the tangents and normals, you can see before, when you use the surface tool to create it from the mesh, it has 27,500, which is the same as the initial import mesh. But after you generate the normals and tangents, you end up with 21,800 vertices. And so now the array bones and array weights no longer match up to the vertex array. And I also tried using d-index on the surface tool and print the vertex size, but that generated like 100,000 vertices, so that didn't help either. So I could get the unique vertices of the surface tool and index them to the unique vertices from the import mesh using the dictionary like I did in import shape keys, and then cross-reference between the two to get the bone and weight value from the original mesh. But I would prefer to use the built-in functions instead of using a workaround. So in the surface tool, we have the set bones and set weights functions, which take a packed array, and this requires you to add the vertexes one by one. It doesn't just set the entire array, you have to iterate as you add the vertexes. So I'll need to loop over the vertexes from the mesh and add the bones and weights as before you add the vertex. So I'll go ahead and make a new function to make the basis, and I'll need to get the surface arrays, and I can get rid of most of this. We still need to set the blend shape mode to normalized, and then I'll call the make basis function. So now I need to loop over the vertex in surface arrays at mesh dot vertex array, and use surface tool, add vertex, with the value, And so if you just run this, it'll say that the begun condition is not true. That's because you need to call SurfaceTool begin before you add the vertexes. And you need to pass the primitive type, which is triangles, to the begin. And notice we're not creating from the mesh or the blend shape, so it's probably best to call SurfaceTool clear here as well, just to make sure. And now if I run that again, you can see that it doesn't throw the errors. And now I want to set the mesh arrays equal to the SurfaceTool commit to arrays. And if I run that, it says that the vertex amount must be a multiple of the vertices required by the primitive, which is 3, because I'm using triangles, and 2700 isn't a multiple of 3. So the original mesh is using an index to map the vertexes, and the SurfaceTool has the add index function, and it doesn't matter what order you call it in, before or after the vertices. So I'll need to loop over the surface array index array and call SurfaceTool add index with the value. And now if I run this again, you can see that it has generated the unshaded basis shape, and it's not currently throwing any errors, and it still is not attached to the skeleton, although it doesn't disappear anymore when you assign it. Now if I set the surface material override, you can see that the helpers are still visible. So I need to add the UVs as well. So I need to loop over the indexes in the vertex array size instead. And then I'll set vertex equal to surface array vertex at the index, and then the set UVs and all the other values need to be called before the vertex is added, because it affects the next vertex. So, and it doesn't have a UV2, this mesh only has a UV1, which I checked by printing out the size of the UV arrays. So this needs to be called before it affects the next vertex, so it needs to be called before you add it. So I'll get the UV equal, and this array is the same size as the vertex array. So I'll get the texture UV, and then call SurfaceTool set UV to the value. So now if I run it again, I can apply the hide helpers material, and now it is just the human form without the clothing and hair. So now I want to set the bones and weights array. So in the SurfaceTool, set bones takes a packed int array that must contain 4 integers, and set weights takes a packed float array that also takes 4 values. So in the mesh, you can see that the bones and weights array contains either 4 or 8 numbers per vertex, and so this will be a multiple of the vertex size. And if you look at the packed float array, there is a slice function that allows you to get a new float array between the begin and end index. So the begin is inclusive and the end is exclusive. So basically I need to get the appropriate slice of the weight and bones array to call for set weights. So I'll get the bones array equal to the surface arrays at the bones index, and I'll get the slice between I times 4 and I times 4 plus 4, since the end is exclusive. So this will get the iterate over the array in chunks of 4 essentially, and then call SurfaceTool set bones with the array. And I want to do that for the weights as well. So now if I run this and reload the skeleton builder, you can see that it is animated now, but obviously that's not what we want. So I'm not exactly sure how to print the array flag use 8 bone weights from the mesh class, but in the generate shading, I can just print the surface arrays bone array dot size, and I can see that the bones and weights have 220,000 values in the array, which is 8 times 27,000, so I know that it's using the 8 bone weights. And in the SurfaceTool, there is a set bone weights function, set skin weight count, which you should be able to set to 8 weights. And in the code, it says it needs to be done before begin is called. So set skin weight count, skin weight 8. And then if we change these to increments of 8 instead of 4, and run it again, so you can see that pretty much all of the points have disappeared again. We just have a sliver, so obviously that didn't work. Although if you, of course, remove the skeleton, the base mesh is still intact. So if I print the size of the bones array that we generated. You can see that the original mesh has the 220,000, but the generated mesh only has 110,000, which is half. So that means it's still using 4 bones and weights per vertex instead of 8, and I can confirm this by printing the SurfaceTool.get skin weight count, which is an enumerator, so 0 is skin weight 4 and 1 is skin weight 8. So I can see that it's still set to the default. And I did find a bug report about this, that the SurfaceTool custom attribute formats and the skin weight count don't work because you have to call it before begin, but then it clears all of the formats when you call begin. So they said that it was fixed here, but I'm not really sure how to tell if they did. And I do have the latest version that was released a couple days ago. So, and just to be sure, I went ahead and set the skin weight count after the begin and before the commit. But as you can see, it doesn't make any difference. It still resets the skin weight count to 4 per vertex. So at this point, I could reindex the original array with the SurfaceTool array and set the bones and weights after I commit to arrays, like I was talking about before, but I'm hoping that they will fix this at some point. And if I print out the bones array, you can see that most of them only have 1 or 2 of the positions actually set, and almost all of them have the last 4 as zeros. So I'm just going to still increment by 8, but only get the first 4 from the bones and weights. So if I run that again, now you can see that the generated mesh does actually map to the skeleton, and it seems like the animations are working. So there may be a couple vertices that don't exactly match where they should be, but it looks good enough to me, so I'll just leave it like that. I may have to reindex the arrays later. I'll see if it causes any problems, pretty much. And now I can call the SurfaceTool generate normals and tangents functions. So now if I run that, and you can see that the number of vertices has dropped significantly. Now the bones and weights are only at 87,000. However, it still works with the skeleton, and now the basis shape has the shading. So the other mesh was unshaded before. So now I just need to add the blend shapes from the unshaded mesh. First, I'll go ahead and remove the make bases shape key from the import shape keys and run that again so that the generate shading will update, and I need to reopen that. So now we just have the blend shapes, and we want to add all of the blend shapes to the shaded mesh, of course. So in the script, I'll loop over each blend shape and call the process shape key. I don't have to check if it's the basis, so I can remove the if statement and align that. And I probably should just clear the SurfaceTool after make basis as well. And then I'll add the blend shapes back to the add surface from arrays. So now if I run it, it takes longer to process, of course. So now all of the shape keys are available. I'll reassign the hide helpers. So now we have all of the shaded shape keys. And it's still mapped to the skeleton. But now we have the issue of the mesh distorting because the skeleton is not the right size. It needs to be adjusted. So this was the problem I had with the original mesh as well that I showed you in the beginning. You can see that it distorts the hands and the neck and shoulders. So, but other than that, this is all working. So I'll go ahead and delete the other two meshes. And I was going to actually build the skeleton. I had planned on building the skeleton this time, but it took a lot more time to figure out how to get these bone weights working. So that's all for this time, and I'll cover the skeleton building next time. So thank you for watching and have a great day.